Hey folks, as always, if you could shuffle in towards the middle, that would help us a lot if there's questions. Shuffle. All right, so today I'm going to introduce you to Sarah. Sarah is a security architect who was previously in infrastructure and networking. Today she's going to talk to us about not being a fail whale and securing your Docker containers.
Cool. Hi. Yes, the mic is on. I wasn't sure if I'd actually put it on there. Hello. Yes, my name is Sarah Young. I'm a security architect at Versant. If you've heard of us, we're an AWS consultancy shop. So we move things into the cloud securely. Well, that's what I'm supposed to be doing anyway. And then we run them in the cloud securely, hopefully. Anyway, I feel like when I say that, I feel like I'm jinxing things, but hopefully not anyway. I worked in tech for about 9-ish years. I kind of lose track. And I've worked in Europe, New Zealand, Australia. I live in Sydney and I'm moving to Melbourne in like 2 days' time. So I like to keep myself busy with doing cons and trying to move house at the same time. So yay me. I overuse memes and GIFs or GIFs in my presentation. So either you're gonna love that or just be like, hey, she has no content, so she makes up for it with pictures. I don't know which way you're gonna go, but hey. I'm also a wannabe crazy bird lady. I'm kind of obsessed with parrots, cockatoos, things like that. So all I do is film my presentations with them because I can't actually have my own one because, you know, life and don't have time to look after them, etc. Yeah. So, also, I've got a really common first name and a really common last name. So I have a lot of alter egos, for want of a better name. One of them is Sarah Young, the Christian author. I also have Sarah Young, there's a couple of Sarah Youngs in Sydney. There's one in Wellington who's a business analyst. And also there's a late 1980s porn star, which I can't do a slide on because, you know, I did think about doing a pixelated one, and then I thought, no, it's going to get me in trouble, so I just don't do one. But so, you know, Google my name with caution is all I'm saying if you want to look me up for some reason. Anyway, so my talk. This is my contribution to this meme that was going around the internet a few months ago now. I was quite proud of it because I think I got 40 likes on my tweet, and that's the most I've ever had on a tweet. But I don't have a lot of Twitter followers, so, you know, whatever. Yeah, so what I'm going to talk about today is security threat modeling. And it's really funny because I've been listening to the talks in this track all day. And Rebecca ragged on Docker, and then Liam kind of ragged on security threat modeling. And now I'm going to talk about all of those things and try and make them sound exciting. I realize if you're a developer, you probably just roll your eyes at this kind of stuff. And as Liam said earlier, it is kind of a part of what we do in security. It is a bit paper-based exercise and can be quite boring, but I'm going to try and demonstrate how it's really important. And in this sense, in the context of containers. So threat modeling for containers. And we're going to talk about the key security threats to containers. Now, you've probably all got your own opinions. Containers have been around, I think, long enough now that it's not a newfangled thing. And people actually, you know, you'll have an opinion. Some people think they're the best thing ever and they're super secure because everything's contained, obviously. Or some people think they're the devil because everything runs at privilege and, yeah, worst thing ever. So we're going to look at how threats and threat modeling will shape decisions made around Python applications in particular. I put this in, and then as you'll see in my talk, I actually struggled to find Python-specific things, but I said I was going to do it in my little blurb, so I've kept it in. And then we'll look at some container-specific tools to mitigate these threats. Now, this is kind of a high-level overview thing. I'm not going in-depth tech here. This is just to give you an idea of the kind of tools you can run as part of your security tool set for containers. So, quick recap of threat modeling, if you are familiar with it. If you're not, here's the time to learn. It sounds cool. There's several different methodologies for threat modeling out there. They've all just got cool acronyms. I think basically the trick is you think of a nice word that you want to use and then you find the letters to fit. So we've got Dread and Stride, OWASP. I've never heard of Trike and Pasta, but I found them online, so therefore they must be real, you know. So they're all kind of much of a muchness. If we look at the definition of threat modeling, or the components of threat modeling. I got this from Microsoft. Like I said, they're all kind of one and the same. They're all similar, but I liked how Microsoft kind of defined these things. So we have an asset, a resource of value, so basically data. A threat is something that might happen to your assets. A vulnerability is a weakness or something that makes a threat possible. And an attack is, well, an attack, you know, that's something that harms your asset. And a countermeasure, or also known as a security control or a mitigation, is something that addresses that risk. That's from the Microsoft Developer Network. It's quite nice in terms of language. So yeah, you've probably all heard those phrases thrown around before. And I can tell you, you know, categorically that if you find them confusing as a developer, security people use them incorrectly all the time. So there's like a nice definition, but you'll find security people use them interchangeably and not correctly. So if you found them confusing, I really don't blame you because, yeah, people aren't good. And I, too, have been guilty of that at times. So looking at how this fits into what I call the security circle of life. Okay. I know this is circle of risk, and this is the second time I've given this talk, and I just realized literally 2 minutes ago before I started this talk that I meant to change that to security and still haven't done it. So well done me for slide quality. So we have, I'm going to start at attacks. So attacks exploit vulnerabilities, which expose you to risks, which are mitigated by countermeasures, which protect your assets, which are compromised by threats, which materialize by attacks. So this goes round and round and round in a circle. And it's important that we look at it as a circle because this isn't like a one-off process you do at the start of your application development. You should be doing this all the time because it never stops. Threats change. So it is important that we see it as an ever-continuing cycle. And I know that will make some people roll their eyes, but unfortunately, securities and threats are always out there and never change, so we kind of have to. So why should you use threat modeling specifically with containers? Nothing is totally secure. I think plenty of people this morning and in the earlier sessions today have said that. I will reiterate that nothing is completely secure, ever. So you need to kind of reduce your risk as much as you can. Your environment is unique, so what may be a very high threat for one person or one organization isn't necessarily for yours. Even if it's the same application, you're using the same runtime environment, whatever, you're using the same libraries or you're not, you can't have a completely identical copy. It is a structured way of analyzing the security controls that need to be implemented, and that helps you communicate to your non-technical stakeholders. Now, I know, again, everyone rolls their eyes going, oh, non-technical stakeholders, blah. But the fact is, non-technical stakeholders generally hold purse strings and allow things to happen. So you need to be able to demonstrate to them why you need things and usually why they need to pay for things. And this is a good way to articulate that to them. And finally, the threat landscape changes constantly. So my original GIF here was Kim Jong-un, because, you know, we've been, well, I say we, I don't want to say we, I should say America. We've been friends with him, then we weren't, then we were, then we weren't. But I actually scrubbed that today because being more topical is probably this one. So, you know, we've got several, well, obviously this morning when I was going through these slides, we had several different prime ministerial candidates, but now we've got a new guy. I've actually literally forgotten his name already. And I'd never heard it before this morning, but the reason for that is because my excuse is I've only been in Australia for 6 months and I'm not up to date with Aussie politics. But having talked to most people around the con, apparently not even Australians understand what's going on anymore. So yeah, I don't feel so bad now. So threat modeling for containers. They are different to your traditional application deployments. And your VMs, they're not the same. What I've seen is a lot of people just go, oh, a container is basically like a VM of sorts. We'll just kind of transpose all of that over. Not really true. I can see why people think that, but no. So we'll look at the common security threats that containers can be subject to and some tools. But this is just, again, like I say, a very brief overview. So do your own digging. Very quickly, this is a nice container implementation model diagram that I stole from a NIST document. If you're not familiar with NIST, it's the National Standards, I forget what it stands for. It's the US National Institute of Standards organization. They do a lot of standardized documents for various different scientific things, including computers and technology. The document they have on container hardening is actually quite accessible. It's only like 10 pages long. Some of their stuff is terrible. Anyway, you can see the sort of difference there, fundamental difference between VMs, and then we have containers on bare metal and containers on VMs. We'll come back to this, but just to recap, if none of you in the room know what a VM is or containers. I hope you do, but hey. So your top threats to your containerized environment from a security perspective are your image, like the actual having decent container images, the orchestrator and the control channel threats to your container, the registry, your host OS, and the runtime environment. I would have said, arguably, some of these things, arguably, actually no, some of these things do apply to other things. But I mean, if you look at particularly your container image and your orchestrator, it's very container specific. I'm going to throw this in because I was told to throw it in and I kind of love it. Thank you, Michael, for pointing me in the direction of this. Obviously, in theory, a container should get rid of all this rubbish and make your Python environment nice and standardized and not messy, but hey. So in theory, that shouldn't be a threat, but hey, you can have messy Python as well. So quickly on how these threats will influence some of your design decisions for the app that you're going to deploy into your container. I think mostly it is actually more related to performance and availability, but just in case you weren't aware, because I have this conversation quite a lot, you have 3 pillars of security, which are confidentiality, integrity, and availability. So us security people actually care if stuff is available as well. It's not just about hacking and whatnot. So this is something that we look at in security as well. Usually it's like what flavor of Linux you're using. I know not all containers have Linux, but I think Alpine seems to be the favorite from what I've gathered, but hey. You might think differently, and do you use pip? Do you use Anaconda? Do you use your native OS Python packages? I'd probably say no, but you need to think about these things and any kind of related vulnerabilities. And do you use virtual environment in your container? And I know that some of you are going to be like, Sarah, clearly you know nothing about Python because virtual environment is like the precursor to containers, and also I'm very keen to hear people's opinion on this, but I've heard some quite good arguments for why you should put virtual environment in your container as well, on top of that. Usually dependency stuff, which is why people use it to start with, but hey, feel free to hit me up after this. And there's a really cute cat because I just wanted to fill the slide, and clearly it's adorable. Cat memes, cat gifs. Also, now Python has security vulnerability alerts. Can you handle those in a container repository or any kind of other alerting you're doing? And do you want to use your traditional application vulnerability scanners before you containerize your app? Like, I'm sure you're all familiar with vulnerability scanners like Qualys and Zap and the other ones that are out there. And so there are some specific ones that are for containerizing things like safety, Dagda, and I have no idea how you say this last one. It's Anchor or Ancore? Like, I want to say Ancore, but I don't know, maybe it's because I'm British, I don't know. And then do you go and scan it again afterwards? I mean, how much scanning can you do? I think these are things, it's more kind of maybe your pipeline than your design decision, but it's something you should think about whilst you're going through. So I wanted to tell you about some really cool Python container vulnerabilities whilst I was doing this talk, but I just found this, and I literally found nothing else, and that's not even a real kind of vulnerability, so sorry. I thought we'd have some really cool specific examples, but that's just some kind of IBM stuff. Yeah. So sorry, I thought I would find something more interesting for you there. Anyway, so moving on to our tools that we can use for containers, we go on to Audit, which I realize is the most dreaded thing for most people who are more technical. But unfortunately, auditors are around and they do have their uses, I promise. So Docker bench security is it comes with Docker. I'm sure you've seen it if you've played around with Docker at all. It tests your Docker containers against Center for Internet Security Docker benchmark and best practices. So it's not really saying that your container is really secure, but what it's saying is, hey, you haven't made any like really noob errors here. And it's good for getting like your baseline if you're trying to baseline images. It's open source, obviously, because it's from Docker, so you can all use it. And yeah, it's your security baseline. It's pretty easy to use. You've basically got no excuse not to run it unless you have something else that you're using. So I would definitely get onto this. It's like I haven't made a complete #fail noob check. For another audit tool, if you're in a more regulated industry, there's a tool called OpenSCAP. You may be familiar with it from other open source environments and other sort of non-container tools. It can, if you're in a highly regulated industry like banking or government, that's the one I was looking for, government. It does actually evaluate your container against those standards. So PCI, which is credit card, I'm sure you've heard of that one. STIG is the US Department of Defense's hardening guidelines. If you've ever actually looked at them, they are the most evil thing in the world because, yeah, I personally have had to check a Windows STIG, and it basically involves like checking about 657 registry values, and it's like painful to do it manually, which is what I had to do. So anything that does it automatically is great. FISMA is another US standards data processing one. A lot of this is very US centric, but if you do any work with US clients or you happen to be associated with the US in some way, you know, and there's still a good baseline, even if you're not kind of actually needing to comply with them. The actual Docker module is called OSCAP, and yeah, it's good for audit activities and regulatory things. And if you do certification and accreditation in your organization, it can really be helpful for that. And you can also throw it at the Big Four auditor people. Just go, here, take this output. So for your runtime security, you've got SELinux. Again, this isn't a container-specific thing, and you may well be familiar with it anyway. It's a Linux kernel security module. It adds access control and security policies to your Linux kernel. You need to be running it in enforcing mode so it actually locks down things. It has a bit of a bad rep for being really difficult to use, but that's sort of only in the last 2 or 3 years. Well, that's in the last 2 or 3 years, it has actually got a lot better and easier to use, unless you start doing some really funky custom configuring rules, which most of you shouldn't need to do. So don't be off-put by the fact it has a bad rep. I would also say that it needs to be monitored, because if you've got, there's no point sort of monitoring things and blocking things and having nobody look at that output, because if you've got something dodgy in your container or some kind of attacker and they're constantly getting blocked by SELinux, but no one's looking at those logs, what's the point? You know, although you are protecting, you're not kind of maximizing it. So always think about this with your security tools generally. Like, it's all well and good saying you've got monitoring, you've got blocking, but you should also have someone analyzing this output at least semi-frequently. Yeah, it can also be used to look at the control channel attacks as well on the orchestrator if it's configured correctly. So yeah, it can kind of move a bit through the stack there. There are other tools as well. Like I said, I'm just going through a few of them here. AppArmor, Aquasec, and I think now Twistlock also do something around this. There's more and more container-specific tools coming on the market all the time now. So. But SELinux is like free, so yeah. For your image security, this is, I would say, if you're going to pick one thing in containers, one security control, make it your image security. Like, make sure you have signed images. The tool that I'm going to talk about is Notary. It's an image repository. It signs images, and it will also update. The software every time things get updated, like the OS, etc. And it means you can verify the content you're downloading and when you're pushing things and containerizing them. This is really, really important because if you have a dodgy image, it's kind of game over from an attacker perspective. There's also a tool called Claire, which is pretty much the same thing. I don't favor one over the other, like as long as you're using something to verify your image. Like this is just so important. If there's one thing you do, please make it this. Make sure you know what you're downloading and that it actually comes from where it says it does. I personally have seen a real life occurrence of an image, and secure your image repository, because I've seen a real life occurrence of an image repository being there, which is great, but basically anyone in the organization could access it and therefore could change anything, and it sort of defeated the object of said image repository. So, yeah. For your heuristics or your IDS, whatever you want to call it, which is intrusion detection system, if you're not aware of that particular acronym, a good one is Sysdig Falco. Again, I'm kind of looking at the open source stuff here. It's based on Sysdig, which again is another open source tool which is not specifically for containers, which you may well have used. It detects anomalous activity. Again, this is the kind of stuff where you need someone looking at this stuff. It's all well and good, you know, processing these logs and something alerting if no one's looking at it. So there's plenty of container-friendly default rules you can implement, and it can be used as an auditing tool as well. I just really love this meme, and this is not mine, but I liked it, so hey, I added it in again. Finally, for your orchestrator control, and I say finally, it's not penultimately, your orchestrator control. Rancher is a Kubernetes management tool. You've probably heard of it. I realize it's not a specific security tool, but it does allow centralized policy management. It can control your orchestrator. I think at the moment, this is like my preferred tool. You can integrate it with your directories, which makes it nice and easy to control access policies. And everyone knows that kind of keeping it simple and trying to have things integrated is way better than managing everything individually. And it can also alert on some unusual behaviors if you're using Kubernetes. And there's an adorable cow, because Rancher cow didn't have a better picture. Finally, vulnerability scanning. We kind of already touched on this. Most of the traditional vulnerability scanners aren't suitable to scan containers, but you can use, but there's a lot of now coming to market container-specific ones. Tenable bought this company called Flawcheck. I think they're now branding it as container security, so you might see both. It's got a pretty GUI, which is why I like it, and it integrates into your CI/CD pipeline, so the idea is you can scan way back before you deploy and stop the deployment before it happens if there's something wrong. And it can scan your orchestrator as well. And there's also Twistlock, I think Aquasec, and there's some more as well. So yeah, that's your... And that's, look, it sits in test there. And I don't know what the weird kind of wave thing is there in that diagram. I just thought it was cool. So where do they fit into container architecture? I don't know why I keep this diagram in, because I realize basically everything sits pretty much in the same place. Tenable, OpenSCAP, Docker, Sysdig all sit in the container. SELinux kind of sits in the container. Rancher, if you're using it, sits a bit down, and Notary kind of floats over here, so that's nice. So the future of this, and more tools. There's loads of tools you can use, just loads. I'm going to click all of these on, because I know I'm running out of time, because I've blabbed. So there are loads of tools. I've just gone through a few of them, mostly the free ones, because, yeah. What is really important to do is when you're looking at security tools, look at your environment and what's best for your organization, because what your friend uses in organization A is not necessarily brilliant for organization B. You should keep trying to redo your threat modeling as much as you can allow. Work with your security teams, like with the whole shift to the left and DevOps and DevSecOps. We need to be sort of leveraging each other even more. And it's a tricky thing, and it's a big psychological shift, I think, more than anything. But it's something that we really need to keep working on, like as devs and as security people. We don't want this, which is the farewell. Of course, I realize that's Twitter, but whatever. Like, it's on my talk and whale, Docker. Yeah. So it was going in. We want this, which is like just my favorite English. So yeah. And here, there's some useful documents and links. The first one's the NIST special publication, which I talked about earlier. It's a good talk about container security by Scott Coulton, who works for Puppet. I've kind of semi-insulted you by like Googling all the things and putting the links on that you could Google yourself. But and then at the bottom, there's some threat modeling tools, which means if you don't really know how to threat model, you can do some basic stuff from OWASP and Microsoft and just put in some variables and it will spew out some output so you can pretend like you know what you're doing. And yeah, that's me. I've got questions, but I typed that on the slide, but I realize I don't think I have any time for them. But yeah, if we do, cool. And yeah, thank you.
Thank you very Hello. Thank you very much for doing that. I think everyone can barely contain themselves.
Oh my God, jokes.
Yeah.
Dad jokes, love it. Thank you.
Thank you very much. And we do have a couple of minutes for questions. So if anyone wants to ask one, just throw up your hand.
Hey, thanks for the talk. And we use Notary, and we found that Notary actually only does the check if you're using Docker directly and Compose, and the other tools don't actually do the Notary check. And we went to Docker to ask if they were going to do that in Compose, and they said they didn't. And I was just wondering, you're talking about Rancher and some of the other sort of control things that you do. Mm-hmm. Do any of those address those issues with securing orchestration? Because Docker's own tools aren't supporting Notary very well.
I don't think like the orchestration, securing your orchestrator, it's not very well developed yet. Google literally released something in beta like 2 days ago. I've forgotten the name of it now. That's all, again, about securing your, I need to read the white paper. I haven't done it yet. But I think, to be honest with you, everyone accepts it's a threat, but I don't think anyone's got really developed tools on it yet. And it's kind of a work in progress thing, the orchestrator thing. The reason I put Rancher in is because it's really a management tool, but it's kind of the best I think we have at the moment. So it's worth having a look at, but I just don't think we've got there's just not the tool set yet and the kind of the feature set. So I think it's kind of a best effort thing at the moment, but have a look, it might work.
I have a question about according to the Docker containers.
Mm-hmm.
In normal life, you type sudo docker run,
yeah.
Name of the Docker image, and everyone is happy.
Yes.
The problem is that I'm not sure, but I can imagine that Docker container don't need such a high privileges.
Oh, that is...
What do you think about running Docker as a non-privileged container?
So I've had so many discussions about this. It depends on who you ask. The fact is that containers, a lot of containerized applications don't work properly unless the whole container is running at privilege. Now, as a security person, that's like my worst nightmare because I'm like, no, do not run as sudo, do not run as root. But I don't know. I think, again, I think this is kind of one of the weaknesses of. I think most of the container work that I've done, we've had to run the container at privilege. And more from a security perspective, we have to look at it more pragmatically and say, hey, this container, this application has to run at privilege. So what are the mitigating controls we can put around that to like limit the blast radius if someone got hold of that container at root and started doing destruction? I don't know, I'd like to think in the future that as containers develop, we'll find ways of not having to run as root or at really high privilege, but it doesn't seem to be there at the moment from what I've seen in real life. It's just something we have to deal with, but I know like security people who aren't as kind of up on containers will just go, no, don't do it. But then you'll have devs saying, but then it won't work. Like the whole application doesn't work. And you've got to find a middle ground there, but who knows what will happen in the future.
This will be our last question as well.
It's not a question, it's a comment. I run a high-performance computer. We have people who do need to run all sorts of code. Mm-hmm. We can't let them run Docker, but they're running Singularity, which is a container, and it doesn't need sudo. So for people who might be interested in that, it's particularly useful.
Oh, cool.
Yep.
Yeah,
Basically, if you want to build it, you have to be root, but if you want to run it, you can run it as a normal user. So it only runs as the user that it is started as.
Cool. I have to look into that more. Sweet.
Awesome. Well, I'll just trip over here. All right, we're going to have a break now, and we'll be back at 4, I believe. So yeah.